Foresight Fight, devlog number 39. I'm starting here in Audiolab because that's what I've been working on. So my focus has been to figure out how to turn this tool from something I use to make sound effects into something that I can also use to make music. I also fixed that thing that was going wrong with some of these sounds before. So if I were to open up Cast Spell, it actually sounds right now. It turned out that when I ported BFXer's code from ActionScript to C, I lost some floating point precision. ActionScript by default uses double precision. I was using single precision, and these calculations for those two parameters involve some very small values which just were not fitting in single precision float. So anyway, I changed my data types and all was good. That was all it needed. Anyway, I'm going to reset this. So you'll notice there's a waveform view there now. I prefer working with this. It's simpler. Waveform doesn't update when I press that radio button. I should do that. Anyway, yeah, so I added a waveform view here just because I thought it'd be cool. And this updates live with slider parameter changes, so I can see things happen. I had quite a little adventure doing, I think it's fun to see what the square duty slider does. How it changes the shape of the square wave and what that does to the apparent sound. Stuff like this is super neat. Yeah, so I had a weird little adventure with... I'm updating this live as I move the sliders around. However, my synthesizer for very long samples isn't actually fast enough to do this 60 times a second, as it turns out, like for the entire sample to resynthesize it. So I had to go into multi-threaded territory. You can kind of see that chugging along a little bit. This is going to be a little unpleasant. It's fine. And yeah, anyway, just the process of getting there was... took a bit of doing. I could tell the whole story, but it's long and meandering, and I don't think I'm going to do that here. Anyway, so got a waveform view, but didn't really do too much else with this particular synthesizer other than fix the floating point precision. So I have another screen here. Let me just walk you through sort of the journey to get from where I was to where I am. So the first thing I knew I needed was basically like, if I'm taking this sound and I want to turn it into music, one of the first things I needed to do was to get this frequency mapped to piano keys. So that took some math that, you know, was basically like, there is a formula to go from frequency. I happen to know that A4 is 440 hertz, and going up an octave doubles the frequency, going down an octave halves it, and the other keys on the keyboard are at evenly spaced intervals based on that curve from there. So based on that math that I just happen to already have filed away in my head, and how looking into the internals of how SFXer interprets this parameter, I just figured out how to map the two to each other. So that was done, and so that gives me the frequency, but then the sequencing, you know, I have to tell the program somehow that I want to play things in a row like this. It's kind of fascinating to me just how much different this sounded to me the first time I listened to it, and it still does. Like this. Whoa. Did that? No, I was messing with this value. That's right. This sounds completely non-musical to me, but like just mapping it to piano frequencies and putting it in a row here just completely transforms it. Anyway, so to get this to happen, I took a long walk where I figured out just like how to organize all this information because, again, I'm using the same sort of design methodology that I'm using with Foresight Fight, where every decision I make here, I'm basing on building it up from core principles rather than just taking conventional things and adopting them wholesale. So I'm figuring out, like, I want a sequence of tones. What does that mean? And just from base principles, invent a system that might end up being something conventional, but if it does, I will understand why and how I got there. So, this gives me a deep understanding that I find very useful. So anyway, I went for a long walk. I thought about what it's going to mean to go from synthesizer to music sequence. Basically, I came up with two abstraction levels of data structure here. Things are going to get a little bit programming heavy here. Don't worry too much about it. Anyway, so what I'm working with for the C major scale is an API that I call audio sequence. Audio sequence is just a list of synthesized samples to play at a particular time. This is measured in seconds with a sampler. So an audio sampler is something that knows how to take audio sampler parameters. These are both abstract interfaces and turn them into sampled PCM data. So audio sequence has list of items to play at particular times and knows how to composite that into an actual a waveform that can be sent to the speakers or written out to a file or whatever you want to do with it. Anyway, so that's the lowest level. This knows nothing about, for example, beats per minute or measures or, all sorts of stuff. Audio sampler parameters actually, I think, does. What does that include? So audio sampler parameters is an abstract interface that has basically nothing in it. I have a concrete implementation using the SFXer synth. This gives me the option to do stuff like, for example, I would have sampled audio that I would just pitch up and down. Like I'd have a recording of a piano playing, and I could change the pitch to simulate playing that piano, or just have a recording of every key of a piano, stuff like that. It leaves my options open, but anyway, I'm starting with an SFXer synth here. And the parameters include just an SFXer params struct. This is just all of these parameters listed out. And this knows how to map. Let's see, in here is the piano frequency math, isn't it? Not here. That's just a data structure pretty much. It's in audio sampler SFXer. So yeah, the audio sequence calls out to audio samplers at a particular time to composite the waveform together. The audio sampler takes the audio sampler parameters listed in the audio sequence and turns them into something real. So render into mix here. Create SFXer sound output from params is a high-level function that just takes a structure filled with these numbers and gives me back PCM data. And where's the interesting thing here? Is it not in... I'm looking for something specific. It's SFXer bass freak from Hertz, right. So the mapping from piano key to note frequency 4 keys C major item index. Anyway, it's... All right, well, I've talked about it, so now I have to show it. This is going to be an audiomath.c, I think. Oh boy, this file. So what is the... No, it's not there. Okay, note frequency. Yeah, what have I done? Okay, here we go. So this is a generic math function that takes... Let's see, this is a few octaves down from 440. So A4 takes octave and key. Power function. Okay, so 27.5. Multiply that up by a few octaves and you get 440. Times 2 to the power of this. Gives you the frequency of a piano key. Anyway, so that's the frequency. Then I have to map that to what SFXer thinks of the bass freak parameter, which is from 0 to 1. Or it can go outside. It's just my slider goes from 0 to 1, but the code will understand other values. And that's in my SFXer synth source file, which is a big mess, but that's how it is. SFXer bass freak from Hertz. That's the formula, if you're curious. Anyway, so SFXer sample rate is 44/100. So I accidentally made a change to that file, and now it's undone. Okay, where was I? So anyway, how I... so this is how it creates audio samples from that list of... No, this is how it creates one sample of, like, you know, this tone being mixed into the entire sequence. The sequence is set up with this API here. So this is a list of the keys in C major. I came up with a better way to do this than just integers, but, you know, it's... So A would be 0. Shoot, I don't have a piano keyboard in front of me. And off the top of my head, I don't know what they look like. I kind of know music, but I kind of don't. I don't know. My knowledge is spotty, as it is in a lot of places. But anyway, you know, this is C, D, E, F, G, A, B, next C. It is? Yes, it is. Next A, next B, next C. Right, 12 keys in an octave. This is already going outside the... So, you know, this is octave 4, key 12, which is the same as octave 5, key 0. Anyway, yeah, so I just make a list of items with each one of these spaced at quarter-second intervals with the parameter of bass frequency being the piano key frequency, and put those in a list of audio sequence. Basically, like, this is testing out my API for compositing an audio sequence at a low level. So that's great. That all works. Put it in a list, piano keys, spaced out, quarter-second intervals, ends up with that output. Great, so that all works. Next thing is to get a higher level audio API that renders down to audio sequence, which can then render down to waveform data. So there's like 3 levels to this. So so let me show you the interface first. So there are 2 components to it. There's music pattern. Here we go. Constants for keys. B means flat, S means sharp. So these are just offsets from or indexes into a particular octave of where that key is, just so it's easier to write in the code. So a music pattern here is a list of notes which are at a particular place within a measure. That's what these numbers are, with a few parameters that can get interpreted by the audio sampler. So I have basically a virtual piano sort of thing that takes things like pressure with which the key is hit and how long it's held, and, you know, which key is hit. That's these 2. Yeah, so yeah, which key is hit, when the key is hit, how the key is hit, and then a field for future use, basically. I guess this could be stuff like, is the pedal down on the piano, for example. And that, right, so the music pattern note, how is this mapped? I believe that's with the music instrument SFX or piano. Yeah, okay, so here in audio, no, in sequence or screen, when I was doing the C major scale sequence, I'm directly manipulating the SFXer parameters here, calling these functions, and putting the parameters together, and directly manipulating the time in seconds. Yep, that makes sense. So then this abstraction layer takes those piano metaphor pieces of data and turns them into what SFXer understands and what audio sequence understands. So bass frequency, this calculation again for the octave and the key. The punch is determined by the note pressure. So like if I hit the note harder, you know, it'll do like this. That's hitting a note really hard. That's not hitting the note as hard. It's, you know, there are better ways to implement that. That was just the way I did it quickly. I'm not even using pressure for anything yet. But that's a thing I could do. And sustain is determined by how long the key is held. So, you know, short hold, longer hold. Would be like that. And then I just changed the square duty a little bit to make this sound slightly more piano-like. You know, this is just playing a square wave. But I think the effect is actually pretty good. So the square duty on this, if I reset U, so that's what this sounds like. Square duty 0.125. Sounds a little different. Kind of changes the timbre a bit, or whatever you call that. You know, it doesn't sound exactly like a piano, but it's, you know, it's melodic. So that's how those are mapped. And the pattern itself... Yeah, okay, so that's how these and these turn into audio data, but then these two are the timing data. So the timing data comes from music pattern rendering to... Let's see, does this render itself? It does not. This is just a data structure. So music sequence contains a list of patterns and pattern offsets. The idea here, this is like a, you know, this is a tracker. A composition here consists of a list of patterns sequenced and overlapped with each other, and within each pattern the notes are sequenced, and it determines which instruments it plays. I'll play you one of my test songs in a moment. I'm getting there, building up to it. So, right. The music sequence structure has a list of patterns and apparently instruments too. How does that... Right, yeah, each pattern has one instrument assigned and an offset in measures. So like if I had this one pattern that had like 3 measures of some melody and I wanted to repeat it twice, I'd put that one instance of that pattern at offset 0, one instance at offset 3, and then it would just, you know, play its 3 measures, then play its 3 measures again. Or, you know, I could put one at offset 0, one at offset 2. So first 2 would happen, sorry, I'm counting wrong. 1 at 0, 1 at 1. So first, no, at 2, yeah. So first 2 would happen, then the third from the first instance would happen overlapped with the first from the second instance. Stuff like that. Anyway, so this can arbitrarily sequence and overlap patterns, and it renders itself to a to an audio sequence, which we've already looked at. Yeah, okay, so here's where the magic happens. I need to know how many things I'm putting in the audio sequence to allocate it. Then after I do the quick count, here's how long a measure is in seconds. 60 divided by beats per minute times 4. This is beats per minute at 4/4 time. I guess you could measure this differently if you wanted it to match your time signature. I'm learning a lot of music theory. I knew some. I've been doing some reading, figuring out the parts of it that I didn't already know. It's fun stuff. So then for each pattern, each measure in the pattern, each note in the measure, it adds an item to the audio sequence with the timing based on where you are in the measure. Right, yeah, so measure length times, what is this? Measure length times something. Yeah, okay, so this gives me the start of the measure in seconds plus the position within the measure of the note's own timing. And the note's timing is determined by beat and beat division. So that's just like 4 quarter notes in a 4/4 measure would be 0 divided by 4, 1 divided by 4, 2 divided by 4, 3 divided by 4. Or if I want eighth notes, then, you know, I could do 1, 2, 3, 4, 5, 6, 7, all divided by 8. So that turned out to be a real useful means of notation, and you'll see how that comes in a moment here. Create audio sampler parameters. Yeah, so this talks to the sampler parameters to get, right, yeah, so this is when the note is played, this is how the note is played, and it all renders out to an audio sequence. Anyway, so long and the short of it is, I have this high-level API rendering out to a low-level API, which makes waveform data. And here on the sequencer, after all that work was done, I could finally go and actually input some data. So this is calling my API to put in a list of notes. This right here is a composition that I wrote a little while ago, a short little song that I just sort of had around and didn't have in a good format, so I thought this would be a good place to put it to preserve it. So 120 BPM, 6/4 time it turned out, 9 measures with this list of notes. So this data creates this output. So that's a little song. I don't know exactly what I think of it, but it's a thing I wrote. It sounds like music, I guess. And I also added this little view here that when I'm displaying a music pattern lines up with the waveform and shows me what's playing when. So you can see how the notes are sequenced here. The faster ones go in between. If I show the whole thing at once, everything comes out very small. I'm definitely going to want to be able to zoom in on this. Because it's a little hard to read just as it is there. So that's pretty nice. Yeah, so the API for this, so it starts with an F sharp and, let's see, F sharp, octave 2, beat division 0 out of 6. What's this parameter? That's the pressure. I'm not doing anything with pressure, so all the pressures are just set to 0. This is the duration. Durations are mostly set to a 1/4 second. Some of them are a little longer, some of them are a little shorter. That's flags, that's nothing, don't worry about it. Okay, yeah, so F sharp 2 at this position, C sharp 3 at that position, F sharp 3 at this position. And yeah, this turned out to be a pretty nice way to input this data. It makes sense to me. This is how my mind works. And for the faster notes, instead of setting 6 to the division here, I set it to 12. So 3 divided by 6 is the same as 6 divided by 12, so either way around, fast notes just have a higher number here. Anyway, yeah, so that's how I'm inputting my sequences, and this is just measure number. So measure 0, measure 1, measure 2, measure 3 has only one thing in it. Right, yeah, there's a long pause right there. That would be measure 3. 0, 1, 2, 3. And that was pretty satisfying. So this needs to be interactive. I'd like to be able to edit here where, when, and how these are placed. And save this to a file, load a file, so I don't have to actually write code to input patterns and stuff. Anyway, yeah, so then I wrote a second composition with a focus on, instead of just this old thing I happened to have around that had nothing to do with anything, I was trying to figure out what would Foresight Fight sound like. So it turned out I don't actually have a very clear idea of what music I want in there. Even, for example, structurally, what are the different tracks? When do they play? So I took another one of my long walks thinking about it and figuring it out. I wrote something just to set something down. So on a blank canvas, the first stroke is the hardest stroke to make. So I made one stroke on the blank canvas of the Foresight Fight music and came up with this. I have some thoughts for how this is going to be used and when and where, but I'm focusing entirely on sequencing right now. So it's just using this one SFXter instrument sample, just basically getting the tones and the timing to do something for me. One single instrument, Anyway, so I wanted to show that just so that I would have a record of, this is what that sounds like. And you might here this melody evolved in some way, probably different instrumentation, probably put together into a full song somewhere, something. I don't know. Maybe I'll decide I hate it and throw it out. Right now, I don't think that. I think it's okay, but I don't know exactly. And yeah, next steps with this are going to be being able to actually like edit this in a way other than just using the API here, and you know, have a file format, have this interactive editor here, somehow be able to place these, move them around, change them, and get different instruments, like what that's even going to mean. Like I could go here and try to make, let's say, some kind of drum sounds out of noise. Like right now, I don't even know. Yeah, I should do that. It starts to sound almost vaguely like some kind of percussion. I mean, it's not very good, but like it's something. I could make a sound with that, a song with that sound as the percussion. Or I might do something else entirely. So yeah, just kind of like exploring the space, figuring out how I want to use these tools to make what I want to make, and also figuring out what I want to make. That's the other part of it. So a lot's going on here. It might not sound like much, but like these basics here represent a good bit of work and a good bit of gained understanding just from a blank canvas to get to where I want to be. And I'm pretty happy with where it is right now, but there's definitely a lot more to do. And again, I've mentioned this a few times. I want to write my own synthesizer code that expands upon what SFXer does. And sorry, I have a little distraction. A bug has decided to sit on my glasses, and it is not going away. Okay, there we go. Right, yeah. So, like I'm saying, like if I want to turn this into some kind of drum sample, I'm not immediately sure how I would do that, and I might need more capabilities than SFXer, which is designed for sound effects, not instruments. You know, it's designed for this. Press these buttons. Be happy with what comes out. Just put them in your game if you want something quick. And I'm using it for something that's not really what it was originally intended for. So I may need a more suited tool for that. But I'm pretty happy with being able to do this with it. Yeah, anyway, so, and then once after editing patterns, of course, I'll need to be able to edit, like, instrument parameters, assign an instrument to the pattern, and then a higher level editor of, like, sequencing the patterns together. Maybe this is a little melody I want to play for, like, 2 minutes straight in the background while I have other stuff also going on. So I have this one pattern track with another one with a different set of notes or whatever input on it, composited together with it. I've used a few different music composition tools, and this is just kind of an amalgamation of what I remember from those and just doing my own thing, whatever I want to make happen here. Anyway, yeah, so that's my state-of-the-art for music stuff. Gonna keep working on it and maybe get back to actual game code if I can figure out what needs to be done with it. Or maybe I'll just keep doing this deep dive until I have something I'm happy with. Like, I'm happy with my progress here, but I'm not happy with this as this is not something I would take and put in Foresight Fight just as background music. That would be incredibly obnoxious. Like this short little loop. You don't want to hear this for, the entire time you're trying to solve a puzzle in a puzzle game. But I think this can be the skeleton onto which I can build an actual soundtrack. That's the first brush has been placed on the canvas. All right, I'll see you next time to see where I am then.